on the computer. Okay. Okay. Yes, actually, that's right. I could click recording on this. No, this one says recording. So fine, it is recording. All right. And the good thing is that when I move on this one, it's actually, I think basically I'll be on two devices and it can record on both of them. All right. So we have a backup. All right. So now you have a pipe. So the pipes are interconnecting, right? You have a elbow here, couple elbows on the pipe. And you have probably a T, well, it's an elbow here, 3 elbows. Eh? All right, good. You have a center section here that it is screwed on. This part is screwed onto the surface. This is your Z-axis, your X, your Y, and everybody can see that. So as I said before, AB distance is 0.4. This is the challenge that I have in this writer. Don't know what have I touched, but the writer is giving me a little block writing, not writing cleaning. I'll continue with it because I don't have an option. So this is 0.3. All right. And this one is obviously I turn on a feature that I don't know how to turn off. This is 0.2 coming down, and this is 0.25 0. All right. So I don't know what is turned on. But it's giving me that little shadow right in there. Let me see. Oh, it's gone. That is a shadow. Okay, finally, I've lost it. It's gone. Thank God. All right, so I won't touch about that one. All right, so so as I said before, don't even bother write them again. These are 0.4, 0.3, 0.2. This is 0.25 for this section here. Here is 0.2. Yeah, this is what I've been trying to find out, how to get that off. So that section. Now, so the first thing you need to do, you need to identify your coordinates point. What are your coordinate points? So you need to go in and first look at what are your coordinate points, write them down, and get cracking right there. So all right, so let's just write down the coordinate points now, and you're gonna tell me them. So the first one, easiest one, is the origin, because this is the origin, right? And the origin is A, and it is simple. So that is 0, 0, 0. So everybody can see that it is fixed. So the x-axis, that's the center of all the axes. And then you have B, right? Can somebody tell me B, C, right? Quickly. What's B now? Hello? Are you guys with me? Everybody is in. I have 15 persons in. Nobody in the waiting room.
0i, 4j,
yeah, man. So
and 0k.
So this one is 0, you said, for x, right? Because it's right here. So only on the B is only on the y-axis. So therefore, the other one would be
0.4j.
0.4, right? And this other point. So I'm just writing a point, not even writing that yet. Another one is so the
0k.
Z is 0. Right, so I'm just writing the coordinate points, not even writing them in Cartesian format. And then C is right down here. So just the X now is all this distance coming down. X is all the distance coming down. I'm picking up a right hand. Where is the right hand? X is, thought I pick up a right hand, it's gone. So X is the distance here. Where's my right hand? Not seeing it. Oh, where is it? Oh, so fine. See it here. So X is this distance here, coming from here. Can you see it coming right down? Right? So it maps that. So therefore, X is going to be what? 0.3 plus 0.25. So it is, so this part is 0.25. This part is what? 0.3. So you add those two together, and therefore, for X, it is 0.5 5. Everybody agree with that? That's
Yes,
good?
sir.
Right? And then now,
Yes, sir.
and then let's put back it in black. Black color. All right. And so that is 0.5, right? 0.5. Right. What about the x? What is the x? What is the x?
We just
You
wrote
mean
X.
Y?
Sir.
You mean
Sir,
Y,
What is
sir?
y?
You mean
Sorry,
the
what is
Y
the y?
axis?
What is the y?
Y, sir. 0.4, sir.
0.4. Good. And the z?
2.2.
Okay. So it is minus 0.2 because it goes below the axis. Do you see that? It comes down here. So it's actually it goes below the surface. So it must be negative. All right. Okay. So the first point we need to write our position vector. So let's write our position vector. So the position vector is of BC. So it's RBC, which is equals to what now? It's gonna be equals to R C minus RB. Am I correct there? All right. But you agree with that? Is that correct?
Yes, sir.
Good. So
Yes,
you
sir.
reverse them in the order, relative vectors. And therefore now, what is C? Let's put C there. I like to do it this way. Because it's kind of it helps you to see them clearly. Some of you can just look on it and just know that you're gonna take the y from the x from the x, y from y, z from z. But just to make sure that you do it correctly, we're gonna write them this way. So it's 0.5, 5. Then this is 0.4. This is minus 0.2. This is going to be b is 0, 0.4, and 0. All right. The end result gives you 0.550. So that is I, J, and K is 0.2 because 0 from that. Right. So that is the coordinate point for that. All right, good. All right. Now that you have done that, that's a position vector. So your position vector BC is equals to 0.5 I plus 0J minus 0.2 K. All right, where do we go from here now? So the objective of it says determine the moment of this force about a point B. So it's going from, so you want the moment about B. So it means there, so now we have now found the position vector because we found a line. We're finding a line, and can I draw that line? Let's get a line there. Let's draw a line. So we're drawing a line. I want to color the line. So the line, let's use red. The line I'm drawing, it is from here going to there. Wow, that is looking so choppy. Can I redo that? All right. So I'm gonna try again. So that's a line. That red line, that's what connecting. So that's BC coming to the force, right? So we find BC because remember now we say I'm gonna find about BC. So you need to find a position vector. So you're gonna find a point from. So you're gonna connect B to a point on the force line. So that is why we need the position vector BC. So now we have found BC, right? What next do we need to do now? In order to find so now we have found the position vector, we need the Cartesian vector of the force because the force right now is in a scalar form. Do you recognize that? It's not in a vector form. Do you agree what I'm saying? Buddy agree? Hello?
Yes, sir.
Talk to me. So just talk to me, man. I am talking to you, so just talk to me because we're having one session here. All right. So now we have so All right, so we need, obviously the force is in a scalar form. So we have this, right? What else we need to do? Because there are a couple of things that we need to do. We're still not finished yet. We need the force now to put the force into a Cartesian format. All right. Now the force is a scalar quantity. So let's identify it. So F, it's a block right now. F is equals to, all right, I'm not using that. F is equals to 80 newtons. So 80 newtons need to be converted to the format. All right. Can somebody tell me how is it that I'm going to convert? What formula should I be using to convert the 80 newtons to Cartesian format? Anybody want to tell me? What's the formula we write? Trying to see my writer. It's getting so. So F is equals to what now? F, the vector F is equal to what now? What's the formula? Can somebody tell me? How do I convert that now? Can somebody tell me? Who remember how that's done? Isn't it this formula? So you get the scalar value times your unit vector. Am I correct? Is that it? Yes or no?
Yes, sir.
Good. So therefore, what do we need to find? We need to find our a unit vector. Correct?
Yes, sir.
All right, so how do we find the unit vector? First, we have to do what? What do we need to do?
Sir, get the magnitude for the vector.
Okay, so we need to get the magnitude in Cartesian format. So we need to convert this to a all right, so look at the triangle now. We are going to look at, so I pre-draw a triangle here. We can see, let's look at it. So now we have there's a line, the force comes down, this black line here, and I even put another arrow there to make it black. All right, which is represented on this diagram as a blue line. The line up top where it actually show its level up top in the plane, in the XY plane at horizontal ground, is this red line here. So that one, so it maps out a 90 degree in this corner. So we have a right angle triangle mapping this direction. Where you see it. Can you see my pointer? Or is it too faint? Too small? So my pointer here is my pointer hovering over the red. Can you all see that? Hello? You can all see that, right? So it's, can you see where I have my pointer at the red?
No,
Yes
sir.
or
No.
no?
No, sir.
No, sir.
All right, you
No, sir.
can see this now?
Yeah.
Okay, so here we have here we have the red line, and it maps out a right angle triangle right here along with the blue, right? So see, I have it here. So this is the red for that triangle. You see it right over here. So if you look on the original figure, you have the force coming down. So the force is coming down, and I have it force in blue. Blue line representing the force here, right down here. All right? So I have it right here. Okay. So I've drawn it right here. So this is horizontal level, the red line. And then now this is a force line coming down. So your force is coming this direction. All right. Then you have a component up top, and you have another component here. All right. Now the angle, so this is 80 newtons. All right. So 80 newton is coming down, right? And this is where C. So that is C. This is down here, so where the force stop. Now, the fact that this is 80 and you have this angle at 30, it means if you use cos for the horizontal, this line up here is going to be 80 cos 30. Do you see that? Where I have the 80 cos 30? That the horizontal is 80 cos 30. Everybody agree with that?
Yes, sir.
Right, and that works out to, you can check the work in 69.2, right? Newton if you're sure to work it out. All right, what about the virtual distance here? So that would have been what? 80 sine 30. Right, that is so big and bold. What that value works out to be? Because those figures are not gonna carry those figures. So that's 80, that's 40, right? So that's 40, right? Good. So right there we have the distance that it comes down. So here we are saying it comes down at 40, right? Right, so that's 40 K. You can call it 40K if you so desire. All right. Now, what about this line here? Can I put a green here? What about this line here now? So we have worked out this line up here. So that line up here is 69. What we call it? 69. The same line I have up here. So the red. The same red line that I have over there in the box. Can I show you the box here? See the box here? This line up here is representing the 69. That red line there. Where's my pointer? So this here is representing. This is representing the 69. Oh, this is so big. 69.2. Right along where you see the red. 69.2. We need to find this distance here. But therefore, they are giving us an angle here, which is what? 40. So that angle right there is 40. So now we need to get the cos of that side. So it is going to be what now? 69.2 cos 40. What that work out to? Can somebody tell me that value, please? I want you to work with me so we can move quickly. So that's 69.2 cos 45. I don't want to use the trig in the problem. It's kind of make life a little bit more tedious if we can avoid that. So we are seeing right across here it is what? 53 newtons. All right. And this is 40. All right. Any other distance we need to find? Do we need to find another distance? And do we have the information to find it?
So where you get the 69.2 from?
The 69.2 is coming from, look. You see where I have the green line? There's a triangle there. Let me draw it in green. So you see where, I'll see if I can pick up that green writer again. Oh, where's the green writer? Come, work, man. Not seeing it, not working. The green writer, get a writing. See if it works now. It's not working. Come on, writer. Where is it? It's all over the place. Let me see if I can find it. All right. The cursor has gone. All right, I see it coming down. Why am I here? I don't want the zoom writer. Where's the zoom writer coming from? That just make matters worse. All right, it is so faint. I'm trying to find it back. When I go green, I can't see the green. Let me use the black. The black is too faint. I can't find it. And let me use a different color. Maybe the orange. I'll find the orange. I'll make the orange a little bit bigger. All right. So we're right across here. See it here? That is what I'm saying.
So
So
is it the 80 cos 30, you get 69.2?
Is 69.2 exactly. Yes, yes. So that is a triangle. That triangle that I have here with the red at the top and the blue, where, let me see if I can get it here. It's this one here. See it here. So right there. So I took it off. This is right angle triangle right here. See it right there. All right, and see it here. That triangle. See it right here in the figure. That section right in the figure right here. I'm gonna have to clean it off again. Right there. Let me clean it up because I can't work with it that messy. All right. Yeah. So you can see it now. All right.
Okay, so
Right. All right. So that is the 80 cos 30. So that is 62.9. Right. And from that now you can get this direction here. See it here? This line right here. Because you already have this, which is now going to be the what? That is a what? The hypotenuse. All right. Let's look good. That's the hypotenuse. Now this is a 90-degree right here. Can you see that one? So this is now, if you see this one over here in blue representing it. So you get that 69.2 right here. This is 40. Can I remove this? Everything might erase. Wow. Oh, it's gone. Oh, everything erased. All right, I'm trying here to keep these things. So so this 69.2 representing this line up here, 90-degree, and this is 40. So now I can get, so this is how I'm gonna get that distance up there. What did we calculate? Did we work it out? I think we worked out as 53. That's how I got it, 53. So this is now this was supposed to be cos 40 times 69.2. Everybody all right with that now? So this distance around here is, can I clean that up? The diagram of too many information there. So that distance that I have right around there now is 53 Newton. Anybody disagree with that so far? Any disagreement there? We good? Hello?
Question. Sir, question.
So we're
sir.
good?
Sir, you hear me?
Yes. Come on. Yes, I'm letting someone here. Who's it? That's only one person. Yeah, go ahead.
There's a quick. So, sir, the 69.2, sir, you say it's the hypotenuse, right, sir?
The hypotenuse
And then-
for this orange line here.
Yes, sir, the triangle like at the top. And then you use the 69.2 cos 40, sir. And that's how you find the 53. And so
Right,
that would have
because
been
that is 69.2. That is hypotenuse, and then now we have another triangle right here now. One out right here. And this
Yes,
is
sir.
right angle right here. So I see a box
Alright.
it out here. I was drawing it over here now, but because it looked a little bit messy, I actually draw the box over here, but it was a little bit messy over here. And I said not serving
so-
this purpose.
quick question, sir, before we move on. For
Mhm.
the F equal to 80 Newtons, sir, this arrow here so would represent the hypotenuse for the triangle that we dealt with first.
F equals to 80 is representing of the force. So the force is happening out there. Yes, that is the scalar value of the force. So the scalar value of the force, the components, its component, to break it down into 3D, you have to work the trig.
Yes, sir.
So you have to work the trig. And you will find other problems like this. So just kind of showing you just have to recognize. I draw this little what cube rectangle.
Yes, sir.
To show you, to highlight. So you see, look in here, you see the blue line that represents the force line right here. All right. When I change right, they are so faint. Sometimes
So the blue line in a rectangle you draw.
yes, it's representing the force. And then up there, the orange here show you the 90-degree right here. See the 90-degree right there? Yeah,
Yes,
man.
sir.
So that show the 90-degree. So each one now, so here now we're able to find a component here for the force, right? So this one represents X. Let me see, this is what? K, and then this distance would represent Y. Am I having it right? No. Let's go again. I think there's something wrong. It's labeled wrong. The Y is the other way.
Yes,
all right now. Come on, where's the right now? Come on. You want to have a cross on it. So this is Y. This is the Y component. So whatever we get there would have been the Y component, which is what? 53. Right? So if you look, the y component, as far as I'm seeing, look like so if we arrow, this component would be going. Where did I tell you this component going? So that would be going. Let me see now. So that is going up here. It's going that way, coming to the end of the box right here. Can you see where I'm marking? Right here. So it's coming down to there. That's the arrow there for that one. So it means therefore the component is going same direction there. So it's going in the positive y. That's what I'm establishing. So it's going in the positive y. Right? So that's the 53 positive y. So this is the y component. So let's put them down. So that's y. So we can decide whether or not they are positive or negative. That's 53 I. Right? And what about the x? The x was what now? The x, what was the x value? Did we work it out? Let's look in to see if we had worked it out. Look like we
Yes, sir. 40 newtons.
No, that's the 40 newtons is the K. So the Z is 40 going down. Do you see that? So that's going down, negative. See there, look. If you look at the triangle here, that is going down. See there? This point, see there? It's going down.
So sir,
Going down right there.
There wouldn't the x. Wait, never mind, sir. When you think of the 69, like, oh man.
Never mind. So okay. So where we are now, let's see if we have messed up our triangle a little bit. All right. So we work out this as 53. Once we find this distance now, so let's redraw this triangle down here. Let's move up a little bit. All right. So we're gonna redraw the triangle with the 53. I'm gonna redraw it. So the one at the top says 53. Come in this direction. All right. Let's see if we have it right. So this was 53. This was what now? 69.2. So we need to find this distance here. That is our x distance. And what was the angle between it? Wasn't it 40? Check that. All right. So we need to check our x component now. So let's work it out and see if it's correct. So here we can use any trig ratio we so do. We can use sine or tan or anything what we want to use. You could say sine 40 is equals, guys, looking that way. Sine 40 is equals to the x upon the hypotenuse, which is what? 69.2. Right? So therefore x is equals to 69.2. This writer is so loud. Sine 40. All right. What's that work out to be? Can we work that out? So that is 69.2 times sine 40. All right. And we are getting 44. Let's check that. 44. I'm going to change the writer. It is too big. 44. Let me clean that up. It's too big. It's pulling up the page. Let me see if I can find something. Clean it up. Right here. I can't manage it. It's too big. All right. Let's see if I can pick up another right. Where is my block? No. Block. All right. Let's see if I can get that. So this is work out to be 44.4. I. Do you agree with that? So that is, so this was K. So this is now 44.4. Who don't get that? Should I go that over again? Might be a little bit messy. Can I go over? Everybody all right with that? Who still don't see it?
Sure, go it over one more time.
All right, but it'll be as quick as possible. I'm gonna just clear up the figure so we can look at it. All right. So let me just draw this quickly. And see if I can get a decent writer. I don't want the writer too big. or when it's too small, sometimes you can't see it and I can't see it. It just lost on the page. All right. So you have, all right, you see this line here? I'm gonna use the line thing to draw it. So from C up to here, see that line coming down now? That is representing a very important line in the start out. You need to recognize that that line is an hypotenuse line for the force. Is that line is on the horizontal, right? So between the 2 points, that is like the diagonal of the box. Can you see it? That's the diagonal of the box. Where is the box that I'm talking about? This is the diagonal for this box here. That box, that box, that box. So you get the diagonal for it. The diagonal is important. That line, you must recognize it is a diagonal and it is up top of the horizontal plane. Can you see that?
Yes,
Are
sir.
you seeing that? Good. So look now. Let me see if I can pick up another color. All right, same color. We're coming down now, which is showing you that is the Z direction that you're going down. See the Z there? All right? And as a result of it, you see when you find a diagonal which is 80 cos 30, can you see? Because the diagonal maps a triangle perfect out, which I have right here. This one that I have right here. This triangle here, see it here? This one right here. I'm just taking it out so you can see it. That one right there. You want me to erase it and draw it back? So that triangle we have there. Let me see if I can draw it back. Pick up a writer. If it will draw. Oh, I need to get the box nice and straight. So you have that box. That is the top of it. And it comes down like that. And it comes this way. So see it there? So that little, oh, come on. All right. Trying to finish it up there. So that now is the angle for that now. The angle for this is the 30. Whoa, come off. 30. So this is 30. Right there. You agree with there? Not 30, you know, it's 30.
Yes, sir.
Wow, just mess it up totally. All right, that line there. Yeah, that is the line that we're talking about. All right. Yeah, so that is it. That is all you need to recognize. Once you see that, you're good to go. So this is 30. Right? You already have the force going down. Remember, the force is going down, acting like a hypotenuse, you know. So you see there? Going that way, and that way in order to get that resultant. So the force is acting like a resultant. So this is why we're saying this is 80 cos 30. Right? Which we work out to what? 60, what was the value? 69.2 tons. Right? And then this one now. So that is that orange line that you have across the diagonal. And then now you must work out this distance coming down, which is obviously going to be a sine. So you could just say, we could just simply say this is what? 80 sine 30. That should give us the same value. Let's check that. No, it wasn't 80, it was 69, pardon me. It was, let me see, what was value we had here? Coming down, what was it? 80 sine 30? 40, yeah. Yeah. So it is 40. This is 40. Right? So this distance coming down, can't write over there because I don't have the space. This distance here is 80 sine 30. Because see, this is the hypotenuse. That is the angle, so that line mapping over there is sine. This work out to be 69.2. Right? You got that? So this work out to be 40. Right? This is 69. Coming down, 69.2 for this orange line. Right. And then you need to work out this. Once you have this now, this is 40. Up here, you have another right angle triangle right here. See the right angle triangle mapping out there? This one right over here. See it here? So this is 69.2, right? 40. So you work out this side now, which is, so you'll give you, it will give you, because look, if I can move this thing, if you look, the distance between here, this distance coming down here, this is the representation of the y component for the force. See it here? All along here is the y. Can you see where I'm pointing there? All of this is the y component for the force. So it is 69.2 cos 40. And you get that value. And the value was what again? 53J. Right? So that gave you, this value here is 53J for that distance right there. All right, so that's enough, you know, guys. So we have the components now. So we can write it, right? So let's write the force in Cartesian format. So we're gonna write the force in Cartesian format because we have to move on. Time is going. All right. And I have quite a bit that I want to go through. Where is it again? Come on, writer. Want a block, and I want it to fine. All right, so over here, the 80 now is now the Cartesian vector format for it now is going to be so we haven't found the unit vector yet. We need the unit vector. We haven't found the unit vector of it yet, but it is so we don't finish. So the format we have is what's the value here now? Let's write them in. 44.4 I. Yeah. So this is right. So basically we have converted we have converted it we have basically converted now. Right? So 44 I times, so it's 80 times this, so it's 80. So the F here represent the 80. This represent the unit vector. Right? So we just writing it out simple now. So it is 44.4, right? Plus, what is the J now? Let's write it down. Give me the J value. 53. Isn't it 53?
Yes,
Plus,
sir.
minus what? 40. Right. So that is it. So we have actually do it. So go in one step. So we have actually worked out all of these values that we work out. Actually gives you the component of the force. Once you multiply the 80 times it, you're good to go. All right, so it's similarly, this is what we have done. So we use a scalar form times the unit vector. So this is working out to the unit vector, the Cartesian format, which give you the Cartesian here. The unit vector times the force, scalar for the force give you this component here, and we're finished right there. Right, so we're good to go there. So now, what is the next step? So now we have converted, let me write it properly. F in the vector format is equal to 44.4 I plus 53. Was 53 flat? I think it was about that. 53.07 J minus 40 K. All right. So that is a little meter. All right. So therefore now, how do we move from here now? They say we want the moment now about a point, not an axis, moment about a point. So it says find the moment of the force about a point. How do we do that now? Anybody want to tell me? So where's the force? Let's look at it. So this is a force down here. We have converted to Cartesian format. They say you must find it at B about the point B. So it means that this distance here is representation of the what now? This is the we have found the position vector for this point. Once you have the position vector times R, we are using what kind of product are we using now to get it? Because we can't use our regular scalar of the moment. So we have, so we need the moment now. What's the formula? Can somebody tell me the moment formula we're using now? So moment is equals to?
Sure, R across F.
R is.
So we are using the cross product. And why are we using the cross product? Can you tell me why we're using the cross product? So this is R. This distance here is R, where we have red. It's R, and we have our force. Because it is a 3D, and we can't use a regular scalar force time perpendicular distance. Right? So it's R times F. Remember, it's not F times R, always R times F. Right. So therefore, you need to put it in the formula. Correct? So the formula, this is going to be what? BC. Pardon me? I didn't get that. Someone saying something? Okay. All right. Let's proceed. The person not talking to me. All right. So let's draw the matrix quickly. Quickly, guys. Time is going. We're gonna draw the matrix now. Where's the icon? Let's draw the matrix. All right. All right. And we have, I'll get enough space. All right. Let's scroll up. All right. So we're gonna move on now. So okay, what are we gonna be writing inside here now? Can somebody tell me what are we be writing here? I, J. Oh, why am I having still having a writing problem? Hold on. Let me erase those. All right, that's a challenge with this software. I'm using it. I, J, and K. All right. So therefore, we go R first, and then F. So what is R now? R is a position vector. What was the position vector? Let's look for him. See him up top there. RBC was about X point 5. Then you have 0. Then you have minus 0.2 for that one. And then F now we had worked out the Cartesian representation of F. But we found the unit vector and multiply it by with the component of it, we break it out. So we're getting 44.4. Right? We don't have to put any I in here. And this is 53.07. And this is minus 40. All right. Okay. Now we are going to multiply it. Everybody remember the rules? What are the rules now? What's the rule? Plus, minus, plus. So that means for the I, positive. For the once we're gonna do it the way we're doing it, for the Y is minus and for the Z is plus. So that is the rule we're following. So you can do this to help you. X, we know, so that is plus. Y, you know what is minus, whatever you get. All right. And then for the Z, right, is plus also. All right. So for this now, you're getting a what? A Cartesian of the moment. You're not getting a scalar value because it's not a triple product. Right? So let's write it. So we're going I first. So you put I here. Hold on. Let me rewrite this. Let me put the, rather than the X, let me just put the I and the J and the K. That will probably make it a little bit easier for some person. So this is I. J is minus K plus K. Right. So let's rewrite it. I'm using the unit vectors in front of it. So this is okay. So let's multiply it now. So we know that the I cancel out and we're only working with the J column and the K column. Right, we're working with these two columns. Everybody can see the columns we're working with. These two here, what we're working with right here. So these two. So the first one is 0 times minus 40. I can put a bracket. Minus, next one is minus 0.2 times 53.07. And I want somebody to tell me the answer for that. Please work it out. All right, the next one, we're doing the J now. So you know that is only the I and the K column we're dealing with. All right, so we're going, the first thing we're going is the 0.55 times the 40. So it's 0.55 times minus 40, bracket, right? Minus, it's now going to be what? 44.4 times minus 0.2. So we're gonna go 44.4 times minus 0.2 bracket. All right. All right. Next one now, K. The K now, your K column is not included, so it's the I and the J. The I and the J are we using we have 4 components here, and we're going to find the determinant of it. So the determinant of it is 0.55. So remember, I know it's determinants, you know. 0.55. Remember, it's 3D matrix is really a determinant you're doing. A part of Cramer's rule. 0.55 times 53.07. Let me make sure the point is here. All right, put that in bracket. Make sure that we have what is minus, very important. And then now, next one is a minus again, what we have here. We probably need to move this guy here. Can I move it? How do I move it again? How do I move it? Trying to, this thing I want to move from here. How do I move? As I'm saying, I don't use the software very often, but I find it has some good features. Trying to move it. When I get something to move here, what do I move? Select object. Ah, good. Right. So I get it to move. All right. So we really don't need it right now. Just want you to see the figure. All right, let's come out of that. All right. So let's finish right now. So going back, we'll do one column already, 0.55 times this 53.3. So we're going this diagonal here. Can you see the diagonal that I'm going? I'm going from 0.55 to here. So we're going that diagonal, then we're gonna go now 0.44.4. So we need to go, say 0 times 44.4. All right, so what these work out to, please? What's the first one? Body work it out. So the first part is 0 times 40 is 0. So it's 0 there. But remember, you have an I in front. And then now what this work out to? Minus and minus give you a plus, not true? And therefore, what that value is 0.2 times 53.07. So that is giving me 100 and, how much is that now? What, that is what? Not 100. 10.6. 14. I thought you guys would work out this already for me. So therefore, this is I is 10.64. You agree with that? All right. What about the next one? We have minus J now, waiting for us. I will put everything, let's work out everything in brackets. So it's 0.55 times 40, minus 40 by right, times 40. So that gives us what? Minus 22. Is it flat? Yeah.
Yes,
Minus
sir.
22.
Yes, sir.
And the next one you're gonna get plus. We already say you're gonna get plus because you have a minus outside. So it's 0.2 times 44.4.
You get
You get
8.8, sir.
88, but that is plus 88.8. Hold on, 88. All right, and what that works out to be now, that's the difference between that and 22. Yeah, so you're getting 13.1 2, if you can just so is that one minus and minus give you a plus. But I agree with that. So that is a So that is a plus, what's the value? 13.12 J, right? All right, what's the next one now? Come again, guys. Let's work out faster now. 55 times 53.07, 29.2.
Yes, sir, I can say that.
Right, 29.2. I kind of round it off. It's really 1/8 there. And I round it off to kind of round it off a little bit early still, guys. To tell you the truth. The other one is 0. 0 times 40, that's 0. So that is basically the answer. So is it positive? Yes, it looks like it is positive. So it's positive 29.2K. So therefore, we are saying here, the moment, let me clean up this now, the moment that we are getting, the moment answer is 10.64I. Was this other one plus 13.12 J, right? Let me fix up that look like a minus there. I don't want anybody mistaking it for a minus. Including myself, plus 29.2K. So therefore, that is fine in the moment. So let's review if we have done everything that they asked us for. So they are saying they just want simply to determine the moment of a force about a point, not a line. So the point is here. You need to connect and get a line from wherever that point is to the force. That is the first thing you need to do, revision. And then now you make sure that the force is in Cartesian format. What we mean by Cartesian format, it must in a vector format because 80 is only in a scalar format. So once you get the vectors, right? You get the vector, you multiply it by the 80. So it's u times f, which is f is the scalar value, or your modulus value. Some people, we don't want to even write the modulus value. Right? I'm tempted to put the modulus value just because I want to tell you that it is a scalar value. This is the vector, right? So we have actually found the unit vector times 80. That is what we have done, but we do it everything because we use the 80, so it goes through one process. So that is really technically what we have done, right? Because we have actually gone through and looked for the components. So we basically work out everything in one here, right? Times 80, all right? You could have simplified the points without 80 and then multiply it by 80 and do it that way. So you could choose to just find the, know what the components are inside, but then now you know that is a unit. Let's say we use a unit of 1. You would still have to, whatever you get, you'd have to multiply it by the 80. So guess what? It's easier that done this way. You have the 80, so you work out. When you have the trig, it will give you, and you have the 80, it will give you the straight value of this. All right? So in other words, the unit vector and everything is in one here. Right? So the unit vector and everything is in this result.
Sir.
Yeah. Mm-hmm.
Which unit vector you'd find to multiply by 80?
So normally when you get a scalar value, you get the unit vector to multiply the scalar value to get the vector value. You remember what I'm saying? You understand what I'm saying? So I'm saying to you, you see along these parts, if you get the unit vector, we could have found the unit vector along the x, y, and the z. Multiply, and when you finish get the unit vector, you multiply by the 80. By fact, that's how we did it. We have actually doing everything in one. That's all I'm saying. In this process. For this particular instant, it's not like you have a line and then so we have done everything. So you could go back and find the unit vector of this, out of this. You could go back and find the unit vector of everything here, out of this. So this is our entire process, including the unit vector, because the 80 is multiplying all of these cos and all of that for the sides. So it's included.
No, I'm saying which position vector turn into unit vector.
I am saying to you that the components, that the fact that it maps components to the various side, right? Remember, unit vector is 1, right? So it maps the unit vector, the 40, for example, map whatever that unit vector is to in this. This way I'm marking. So the 40 to this side would have mapped your unit vector component for your y. That is the angle, of course, I'm talking. This one now, you would get the 30 would map the equivalent unit vector to this side. And likewise, these. The fact that we multiply it, use the 80 when we're multiplying it, we are doing everything in one by using this formula. So it's the scalar value and the unit vector. Everything is being done in that because it's a trig. You get what I'm saying?
Okay.
Good, good. Right. Yeah. And the trig, remember the trig has a ratio. So I'm just saying the unit vector is normally 1. But if you, so that means if you work out the ratios without the using the 80, those would have given you back the unit vector. Right? So the unit vector really is as I tell you, the value, it will be cos. The first one for I, let me explain for you. The first one for I would have been cos 30. Let me give what the value is. It would have been, for the diagonal, it would have been cos 30. The value of cos 30 times sine 40. Let me tell you what that value is. So that value would have been 0.55. So the 0.55 is really the unit vector that you, once you use that, so you see the 0.55 right here, that 0.55, it will help you to get the unit vector for all the sides here. The 0.55. You understand what I'm saying? Because one is 30 down here, right? And the other one over here is 40. So it gives you the unit vector for the x. So the unit vector for the x would have been 0.55. Right? And for the cos, for the y, it would have been cos 40 times cos 30 times cos 40. And for the z, it will be sine 40, which is what? Sine 30, which is 0.5. So that we're saying is actually the unit vector for those. So the trigs can give you the straight unit vectors. All right, so let's move on because we don't want to stay the whole night on this. We have done an hour on this problem alone. Let's move on. All right, so that problem is finished. We are going to move on to another problem now. All right, let me see. I have a number of problems. All right. This one is about a point. No, I want to get up another problem. I'm gonna look for another one and drop on this. Not this. Let's get another one. I'm gonna get another pipe. All right, here we are. Let's put another pipe up here. I'm gonna copy the entire thing and come over in the Zoom page here. Let's see if this one will drop here. All right, here we are. All right, so this is a pipe. All right. I'm gonna have to pick up the diagram separate. Probably might not work out too good. All right. All right, so the pipe, I want a better picture of the pipe. Let me carry the pipe separate. Can I carry the pipe separate with us? So we can analyze the pipe. All right, so I'm going to pipe separate because I need to hasten with the time. Let me see. All right, so the pipe here is all right, so this is the pipe. All right, what they want from us now, I just draw it big. Come on, don't mess up All right, let's say here you must determine the magnitude of the moment of the force F about the X, the Y, and the Z axis. So now this is about an axis. I put triple product here because in our process, the triple product technically comes in. You see that? All right. All right. The first thing, first one we want to do it about the let's start with the x-axis. All right. How do we do it about the x-axis? That is the first one first. So let us move on to the x-axis. All right, so the x-axis, let's look at the figure. I want it to come brighter. We see that is Z. Let's see if you are seeing what I'm seeing here. Everybody seeing the page proper? So this is Z.
Yes,
This is
sir.
Y. And this is X. All right, pick it because we're going to have to move on. It says you want the position vector. So the first thing in solving this problem, we're going to use the Cartesian vector approach. Right? You're going to find the position vector of AB because look where your force is. Your force down there, your force hanging off at some point is 4I, 12J. This one now is in a Cartesian form. So it's not in a scalar form like the 80, but it's in a Cartesian format. So it's 4I plus 12J minus 3K pounds. That's the unit. All right. So it has a component. So, right. So you can say that for the in the I direction, it is 4. In the Y, it is 12. And in the Z, it is minus 3 going down. Can you see turn down? All right. So the first thing we need to do, we need to find the position vector of AB. What's the position vector of AB? Firstly, let's identify A. Come, let's move quickly. So A is at the center where all the axes meet. So you already know that the coordinates for A is 0, 0. What's the coordinates for B? Come quickly. Somebody help me with that now. What's the coordinate for B? What is X?
4, sir.
4, 3,
4.
-2.
4, right? So far in the X direction, it is 4, right? Because it's right here. So for B in the X direction, if you map it over here, it drops right here too. So that is 4, right? What about the Y? Somebody, what's the Y?
Sir, 3,
Somebody
sir.
else
3,
tell me
sir.
the Y. The
3,
Y
sir.
is 3 because it on this C and B is on the same line of the pipe. So that distance is 3. Right? Okay, cool. What about the Z? Can somebody else different tell me about the Z? What's the Z component now, please? For somebody else? Who else want to tell me that? Taylor?
-2, sir.
All right, good. Thank you. I love that. All right. So we have, so from that now we can write that RAB is equal to what? RB
RB minus RA, sir.
sorry, RB minus RA, right? Where did I get C from there? That's going too fast. All right. So RB, let's write it down. Is 4, 3 minus 2. I tend to write it this way because I'm just trying to make sure that persons don't make any mistake. You can take it, if you can do it mentally, fine with me. Just do it. But I'm just making sure. So the fact is, this is 0, 0 in this case. So technically, you know that B is really RAB. All right? So if it is 4I, 3J, minus 2K. Everybody agree with that? All right, so that is position vector. All right, now that we have the position vector and we have the, so we have two components. We have RAB, which is really equals to, in this case, is 4I plus 3J. And I use this example because it's quick. This one is now about axis. Remember, it's about an axis, but we don't reach here yet. First thing you need to do is find a line from the point of wherever that axis is. Now, A maps onto the x-axis because we are finding about the x-axis. So A maps it on. If if this, for example, was, let's say that this was D up here. Could we use D, argument's sake, could we use D to find a position vector that maps it to that line? I'm asking a question. Could we use D? Asking a question. Could we use
I don't think
D
so. I
if
don't
D
think
was
so,
up
sir.
here? And hypothetically, could we use that? So you want a line that maps it to the point. All right, fine. So let's move on. All right. That was just a question. All right, so let's move on. Now we have the position vector. You need the, we can apply the moment. We can take the moment, eh? Right? But is it finished if when we take the moment? Is it finished? What about the axis that you're gonna take it about? Can we, is it not the triple product that we are working with? Everybody remember what is the triple product? So the moment is typically what? R times, in this case it's RAB times F, right? But because we're finding about an axis, to get the triple product about the line that we are doing it, the line we are doing it is the x-axis. So we need the ux axis, the component of the unit vector of the x-axis times this. Oh, by the way, I shouldn't write it this way, but I shouldn't write it that way, technically. Right, because it shouldn't be written that way. Because it's all cross product, okay? We're gonna get a scalar value anyway. You are gonna get a scalar value from the triple product. Do everybody remember that you get a scalar value from the triple product? It could have read that way. So you dot it against this, you're gonna get a scalar product. Everybody remember that? So this is ux. So let us write the format that it's in, please. So it's really going to be this need to, let me just fix up this. Let's rewrite it over total. So it's the axis that we are concentrating on is the x-axis. Let me see if everybody getting the clarity. The axis that we are concentrating on to do it about is this point. However, A is on this axis. So that is why the first thing we did was to map. First thing we did, let me write that over. Let me use a tool. See if I can get a better writing. So I'm saying, let me draw the line. So that line maps the force onto the axis. Everybody agree with that? So that gives us BC. That gives us RBC. Come right, still not coming off. Right, so that gives us RBC. Right? But away from that, we need the unit vector. We need the unit vector of that line. And the unit vector of x-axis.
RBC? Isn't it RBA?
Pardon me?
Wouldn't it be RBA?
RBA. It's really
yes,
AB.
the line is connecting B and A.
It's because it's the distance. In this case, it's AB. We can label it AB because it's going from A to B. You can label it AB. I wouldn't reverse it.
Oh,
Right?
sir, you wrote RBC for the line.
Sorry. My bad. It's AB, sorry. I'm sorry. Yeah, I was wondering what, yeah. Okay. Sorry. Because there's no C. Is AB we're talking about. C is not included. Pardon me. Let me just clean up this when I was writing it. Okay, so let's go. All right. So let's do it. So I'm just making the point that A is on the line, the axis that we're finding it about, which is critical. Right? And that is why we have gone out to A. Right? So that's why we found the position vector AB. But what is the unit vector along the x-axis? Can somebody tell me the unit vector along the x-axis? Let's identify that before we move on. So the unit vector along x-axis is what?
1I 0J 0K.
So it's 1i 0j plus 0k. Everybody agree with that? Who don't agree with that? Okay, so we are good there. So we have the unit vector ux. All right, and now we're gonna put it in the triple product. So the triple product is written this way. Let's write this nice and stylish. No, not my bad writing up there. Let's draw a nice thing here. So the triple product, you must put the u first. Did I rewrite the formula as I was supposed to write? I didn't rewrite it. So we're finding u. Oh Lord. We're finding, let's see if I can write that again. So it's really u times, you're adapting it times the r a b times f. Right? So you're getting a scalar value for that. It's a triple product. All right. Oh, I need to move that from there. Eh? That's not where we're gonna write. Oh, I can't have it there. So it's u dot r a b times f. All right. Yeah. All right. So let's erase what is down here. But we need this line. All right. So let's go. Let's put it in now. So we know u already. Let's put it in. So it's the value is 1. So I is 1, j is 0, k is 0, and r and f. So this is u. So r now is 4, 3, minus 2, and then the force now was 4i. Everybody remember the force over here? See there? So the force is F is equals to 4i given 12j minus 3k, and all that was in what? Pounds. So let's go. So we're doing one of them where we can do, and you guys can work the others. So this one was what? 12, positive 12. All right, take out the I out off of it because it's not needed there. All right. So this is 4. All right, the next one is minus 3, which is a k. All right, so we just need to do the multiplication of this. All right, so for the x value, well, we don't really have an x value here. Everything can multiply out together. We can beat down here because it's a one scalar value we're gonna get at the end of the day. So it's 1 times now. So remember, this represents I, this represents the j, and this represents the k. So it's 1 first, bracket. Then we're gonna use find the determinant now. So we're gonna go, let me show you before I do it. 3 times 3. So it's 3 times minus 3. Bracket minus 2 times 12 bracket plus the others now are going to be what? You notice they are going to be all 0. They're all going to be 0. 0 times whatever. 0 plus 0. So that is easy in this one. So the value is really equals to minus 9. And this is going to be plus 24. Right. So the answer is what? Positive 15. And this is what? Pound. Right. So that's positive 15 pounds. You do the same thing for so this is for the x-axis. For the y-axis, you would have put 1, 0, 0, 1 up here. So you'll put 0, 1, 0. And for the z, you would have put 0, 0, 1. So you'll keep using the unit vector for the different axes. In this case, it is all about the x, the y, and the z axis. So this is easy. So for the others are pretty straightforward. So I'll just do one of them. And that is about finding the moment about a what? An axis. And the triple product gives you a scalar value, which is what? In this case, 15. When you find about a point, you will get a Cartesian. All right. So I'm done there. So we move on. All right. All right. I have another question to do. This one is going to take some time. So let's jump into it right now. All right. So we have 2 more questions to do. I want to do a frame and I want to do one more problem here. So let's jump into this one. Where is it now? Hold on. No, not this one. I want to do a frame here. Where is it? Yeah, here we are. All right. So we're gonna use the slide. To the interest of time, we're gonna use this that I have here. Can you see it? Hello? And this is gonna be long, so I'm going to just use the slide and go through it. All right, and you would have seen this problem in your textbook, all right? So some time ago, this was used for an exam, and I'm gonna go through it quickly. So the problem says, and what's the wording for it? It says the figure below, a balloon, so you have a balloon here, is subject to a net uplift force F equals to 8 newtons. You were to find the tensions in the cables. So you have a cable AB, AC, and AD. You are to find the cable. So the force, the 800 Newton force is F. F value there. So you have a value. So you know that this is an equilibrium problem, right? Do I have a writer here? Yeah, I should. Let me go slideshow. Right? So here you will have, so this is 800 Newton. Right? Now, firstly, you need to recognize the original problem, you would not have these points. You have to look at it and say, what value is A? A is, now, where is it? Where is the Z? So the Z, let's look on where the Z is. You have see the Z here. So the Z axis coming down somewhere in the center. Where is X? See it here? This is right here. So this is your typical your 0 point. So your 0 right here. So your 0. So for your Z up to A, it's 0, 0, 6. So that's Z is 6K right there. So the coordinate of A is that. All right, so we can recognize that A is, oh Lord, I need a different color. This black, this red is drowning me. So this is 0, 0, 6. All right, what is B now? So you need to do every one of them. B now, if you look, and you wouldn't have seen this in the drawing, you see the answer there, but let us look at it. I pity I didn't grab the original one from wherever. All right, so B now, you need to look for B. This is 0. This is 0.2, but this is going beyond for Y. So you know that is Y is what? -2. What is X? X is going over here. So the X value here is what? 1.5. So, and it is minus because it gone over this side of the quadrant, right? It's over here, which is 1.5, and it's minus. So it's minus 1.5, and then, and so that is X value. What about the Y? The Y we said was what? 2. See 2 here? This 2. Right? 2 maps it over here. Maps it to that distance. And it is minus. So it's -2. And then, what is Z now? Does it have a Z value? No, 0. Because it's right at the origin. Right? What about C? Let's look on C value. Let's read it off back again. So you look for C here. Right? And you say, okay, what is X? And you look for where the origin is, and you plot it back over here, right? What distance are we getting there for your Y? Your Y is 3, see there? But it is -3. Do you agree with that? Because it's behind where the origin is, and you see the 3 right here, so it's -3. So that's Y. What is X, by the way? X is 2. Is the x2 over here, which maps it right to here, so this section here is 2, and it is positive, right? So this is minus 3. What is your z again? Your z again is 0 because it's level up. All right. Is there any more point? D. So D is these on the y. So the only value you have here is 2.5. Everything else is 0. 0, 2.5, and it's positive. So you write those down first. Remember, right? Whenever you get a problem like these. All right. So now we have these problems, these solutions, and I'm gonna go quickly, just walk through this. All right. So here now it says you are to determine the position vector of the 3 cables pointing away from A. So they are all pointing this way, that way, that way, right? So that means you want AC, RA, we'll write again, RAC. Wow, that is so looking crappy. So let's rewrite that. So you need R AC, you need R AD, so you're going that direction. You need R, we have AC or we have AD, we need AB. All right, so you simply do the same thing before, right? And you write them. So you will get AB, as you can see, is going to be AB is minus 1.5, see here? So you get AB as this value, right? Because it's B minus A. So you get 1.5 I minus 2 minus 6. All right, cool. And then you find the modulus of it, which gives you 6.5. Once you get the modulus, you can get the unit vector of it. All right. You then proceed to R AC. You do the reverse, same thing, I get the position vector from those points that you have. Remember, I already have the points, you know. So you take away A from C. Right, and you know A was what? 0, 0, 6. So 0, 0, 6 from A, from C, where's C? C is 2 minus 3. You take away, you're gonna get, because remember these two components were 0, so it's only the 6 alone for the Z. So you see there the value is 2I minus 3J minus 6. So here RZ, the modulus is 7. And that lining up now to use those values, you know. And then you proceed, you do the same thing with AD, A going to D. So AD is equal to RD minus RA. You subtract A from D. A was this value, 0, 0. And this is what? Sorry, 1 second, guys. Let me plug in this other device before it shuts down. And you can't hear me. 1 second. So this is normally one of the more challenging questions that you may get somewhere along the line, and you need to be with it. So AD, so you get the position vector AD, you subtract D, where's D? D is right here, 0, 2.5, 0. And then you simply, is there anyone who need me to break up? Not understanding? Remember? And you subtract A from it, 0, 0. So 0 from 0 is 0. Y is 0 from 2.5. So it is going to be 2.5. 6 from 0 is minus 6. So you get those. You get all the points. You find the modulus. So right here now we need to find the unit vector of all of the unit vector of AB, AC, AD. All right. So it says determine the magnitude of the tension in the tree force. So you know the modulus times the unit vector. So the unit vector is always going to be the position vector divided by its modulus. So for each one, we found the position vector before. All right, so AB was minus 1.5i minus 2j divided by the modulus of the found around here, all of these values here. So we do it for them individually, 6.5, right? So I can send you this, when I'm finished, I can give you the PowerPoint of this workout, right? All right, courtesy to Ms. Roden. All right, so, because I didn't have the time to do it. I'm happy that she has this worked out. So, and type properly. So it's UAB is equals to 313i minus 4, right? So for each one of them, you get the unit vector. So AB is that, and this is the unit vector for AB. All right. And then you simply go again and you find a unit vector for UAC. So it's a little process. This is just teaching you to find unit vector, and after that you can simply find the force. You find the unit vector of this other line here, UAB, because you had the position vector divided by the modulus, and you get this value here. Fine. After you have done that, you will have unit vectors all along the way now. So now, what's the next process? It says,
Why over 13?
pardon me?
Why over 13?
What is over 13?
The
What was the
5 and
value
the
around
12.
here? Let's check the value around here. Let's see if there's, what was the value around here? What was the value? Oh, this was supposed to be over what? 6.5. So the modulus was 6.5. Let's see if there's an error there. Which one is
No,
over?
sir, there's no error.
Where,
All
where?
values were multiplied by 2, the numerator and denominator.
Oh, okay, cool, yes. Oh, you're right, right. So this was multiplied by 2 and that was multiplied by 2. So this becomes 3, this becomes 2, it becomes 12. So what you simply did was multiply top and bottom by 2 and make it a little bit easier. So the fractions that you have here are easier to work. All right, cool. And then now you just simplify the decimal of it. And you could just do it one go from up there. Right? So right, you have the unit vector for all of them. Now that you have the unit vector, right? So it says you were to do the magnitude of the force times determine the magnitude of the tension in the 3 ropes. Let's continue. All right. So you found all of the unit vectors. Having found the unit vectors, you can now find the force in each one. So the force in FAB is the modulus of FAB times its unit vector. So you don't have the modulus, right? So you write the modulus in, you multiply the modulus by the unit vector. The unit vector of AB was what? UAB, it was, where is it again? See it here? This right here. So you remember now. So we can actually pick it up on carrot and show you. So see it here, that value. Where are we now? So it's right here. That value drop. Can I get a, oh Lord, I can't get that thing here. That thing not piercing here. So I was trying, this is not. So you put the, you just multiply FAB times the unit vector. Same thing. Right across. So you give component. And you do each one of them. So for AB is FAB times whatever unit vector you have. This is a representation of the force. You don't have the value yet, but it's a representation of it. So remember, first thing you get the position vector. Second thing you get the unit vector. Then you must use a formula which says F times the unit vector. So it will give you this formula. That's that equation. That's the first one. And you're gonna do that for every line. So for this, for AC, you do this very same thing. You're gonna go FAC times its unit vector, because each one for the I, for the J, you're gonna have it there. So see it here now, going right across. Everybody remember what was the unit vectors? Right? I can come out of this, probably I'll be able to keep if I come out of this, so you can see it. The unit vectors, if we can just backtrack, see, all of the unit vectors are these. All of them, just backtracking, showing it. So these are unit vectors. And all we do is multiply FAD by each. So if it's FAD unit vector, you multiply FAD by it. See it here? So for all three of them, that's what you do. Remember, the problem not finished yet, you know, but it's a stage by stage process. Anybody need any clarity right there? Anybody don't understand so far how we got to those points? And listen to me, this class, no broke on a shame glass, you know. This is one class, and we are working as a team to accomplish an objective. So I want you to work with me. All right? All right. All right, you all are silent. So, okay, the fact that we have done that, we know. So, listen to me. The fact that you have done this now, you are now going to pick out from each of the force all the I component, all the J component, and so for the X values, you are going to compare them for each. You're gonna group all the components them together. Everybody remember how this problem is done? So you look at what the first one is this. The first value is this. Can I put it somewhere that you can see it? I don't know if I put it around here. So you put this one around here. Can I get a paste? Will it paste? All right. Oh, I'm gonna do the forces. I don't want to paste this. I'm gonna look for the force and put them just to show you the clarity. Let's look for the force them individually and just and compare them. So the force is this one. Let's copy it. I'm gonna carry them around for the clarity. So that's FAB. Put them down there. All right, so that's the first one. All right. Okay, we're gonna go for the next one. Another one. AC. Try to go as meager as possible. So you put them here. Next one. Oh, come on, don't do that. Oh, undo. Let's see if I can get a place somewhere else. I'm moving. Okay, supposed to move. Okay, so we have that one. So that's second one. We need the next one. We need AD. So AD is right here. Where is it? So AD is here. All right. These are typically the type of questions that you would get at this stage for these type of problems. All right. So right there you have them. All right. What is the next? Can somebody tell me what the next process in order to find the actual value of AB, AC, and AD? What is the next process here? Because this is an equilibrium problem. What's the next process? Come on, guys, quickly. Hello? What's the next process, guys, please? Nobody with me?
Sir, you put them for the into the FX, FY, and FZ, sir.
Okay, good. So we compare them and we look. All right, so let's look. Let's just look at them. So here you see all the X values. Here, you see what all the X values are, and you see all the Y values. You compare them and all the Z values. So it will lead you now to this point where you have X is equal to this equation. So these are the three equations that you are getting. All right. So you get these three equations. Just compare what you have around here to this. All right. Let's see if I can move this thing up. The pace over this. All right. Right. So what you do, you will look for all the x and x value. See there? So the sum of f of x function, you take them off from the x components and you write them down. You do the same thing for the y in blue. So you see it's sum of y and you have them written out, right? Equal to 0. And you do the same thing for the z, right? So you go and you do the same thing for the z, equal to 0. All right. Now, what you have here are 3 equations, and you have to have a little bit of experience. So if you don't practice this, you might end up in a little problem that you cannot work out these simultaneous equations. How would you solve this? Can somebody tell me what's the easiest approach to solve it? So you have equation 1, equation 2, and equation 3. What's the best way to solve a problem like this? What would be your approach? Which 2 equations would you work with first? Because what you want to do, you want to substitute one into the other. Right? Can somebody tell me what would they do? So you have all of them written together. You have the x, you have the y, and you have the z. Right? So right there, you yes?
Probably I put equation 1 into one of the other one.
All right, but you need to put it into one that you think that would be advantageous. All right.
Equation 2, sir.
Huh?
Put
All
it
right,
into
you
equation.
can. But, all right. With these problems, though, you have to do it a little bit by inspection. Let's look at the next slide. So what I did in this one here, you're going to equation 2 and equation 3. So what they did was equation 2, they multiply 2 by 2 and then add it to equation 3. Right? That's what she did in terms of working it out here. So if you substitute equation 2, so 2, where's 2? 2 is this one here. So you could substitute 2 into 3. That's what she did. So what she would, well, I would definitely use this one of these. But I tell you, if you're not be careful, you could end up with a long process. So all right, if you look in this one, you will see A, AC, AD. If you transpose one of these, quite simple. You transpose one of these, you could make, for example, you could transpose make AB with the subject and put AC. It means that anywhere in this equation, one of these equations of your choice, you're going to substitute that value in the other equation. What it means is that you are going to just end up now with, and you have to be very careful because it means that you may have to do the process 2 times, right? Because it's 3 equations you have, and it's you have to do it by inspection, right? These 2 have 8 in it, right? So I see that she circled it because everybody have a different approach. She circled 8 because 8 is in this one, right? And you have 8 here, so right? So because Z, so let me just point out, how did we get the 8? Anybody remember how we get the 800? How did we get the 800 with the Z before we move from there?
The force going upwards at Z.
All right, because look, if we go back to the diagram, for those people who don't remember, this part is crucial. If you forget this part here, you're gonna get it wrong. The 800 is going up, positive Z, so you need to add it to your Z equation. Right? You need to add it to your equation, right? For your Z component. So let's look back at the equations that we had. So for Z, you have to put it in. So it's a positive 800. You can't miss that. Whatever force you have, if it was going down, you would have to put it as minus. Right? That is crucial. But as I said to you before, here it's just a matter of substitution. Right? what she did was to multiply equation 2 by 12, 12 upon 5, and then add it to equation 3. Right? So that's what she did. Right? So she multiplied equation 2 by 12 upon 5, right? And then she add it to this equation here. That's one method. And she got components here in what? AB, AC equal to minus H1. So she has, so what she technically is, she got another extra equation. She got an equation 4. Other people may choose to do a transposition, but these things are solved by inspection, because if you use the wrong method, it's gonna take you a longer time, right? Because you typically want a nice, smooth, simultaneous equation. So what she end up with, so what she did that, she get another equation 4. She's now going to transpose from equation 1, just like I said before, and she make now FA in this stead equals to 0.8070. So in all, she have 5 equations. So you haven't transposed to FA, right? And equal to that. All right, let's move to the next section. So the next section, she substitute equation 5 into equation 4. Let's look back at what was equation 5. So in equation 5, you only have 2 components, AC and AB. And she put it in this. So wherever you see FAC here, she takes that and drop it right there. What that will do is get everything in AB. Right? And she's simply going to solve for AB. So let's look at the process here. So you substitute it into equation 4, you get wherever, so that was this equation, you drop this value here, you get everything in AB equals to what? 800, right? So so you get everything equal to and you carry it over the bracket, so it becomes minus. You work out that, add them, you get minus 3.18 equals to that, and you divide. So you get an AB value. Once you get an AB value, you go right back to equation 5 where you add FAB equals to a value. So it adds this, FAB is this value. You're going to substitute FAC was this time AB, and you simply just drop it inside here, and AC drop out. Now you only have one unknown, and that you can just substitute in any one of the equations and you get. So anyone, you could choose to do it in either equation 1 or equation 2. Anyone that have AC, AD in it. One of those equations have AD, and AD was in, I think, yeah, you had AD in number 2, right? I remember all of them. Whichever one have AD, you just substitute AB and AC in it, and you'll get the last value. But as I said before, you could follow this method. I will give you the slide. And this is a nice workout of it. You have a problem that we did in class, right? And I don't remember the method we use. I know we use substitution, or we form a simultaneous equation, and we solve. Right? But there are different methods that you can use. The next part of the question. So that need the value. So look, let's review. The value of FAB, of AC, all of these values are found now. And then the question says, determine the magnitude of the tension on each cable. So we did that already. It says, determine that, what else did it ask? So express the tension in the rope AC in terms of the coordinate angles. So the coordinate angles, FAC is as a value times its unit vector. You would have pick up back its unit vector. This was a scalar value that you got times its unit vector. So you need to break it down using the unit vector. You'll get it back into what? A Cartesian format. But looking at these, once you have these are giving you the angles. These are giving you the angles that you need, the coordinated angles. You don't even have to go further than that. It's just the cos of all of these. So this is giving you alpha, beta, and gamma. Right? So it's the cos inverse of each one of your unit vector, typically, and you'll get your angles, right, from FAC. Right? So I will give you this slide. in the interest of time, I had to just use this, right? And it says how many newtons of the tension in AB is projected along rope AC. You see this thing about projection, make sure you understand when we say something is projected from one point to another. Projected, so this is so extra credit here about projection of one line to another. It says AB, where's AB? AB is this line around the back here, and it is projected to AC. See, it projected to AC here. So the angle, we found some angle before, did we? What we found around here? Okay, we didn't find anything. All right. The angle between, so you can find the angle between the two lines. Because you have the two lines position vector, and you have them unit vector too. So you can use your position vector or the unit vector, right? The unit vector, it might be easier than the position vector because it already works out. You have the unit vector of AB, and you have the unit vector of AC. And once you take the cos inverse of it, because this is using the formula. Everybody remember the formula that we're using here? So this same formula here, man. You normally see it in this format here. Where's the format here? Can I get a writer here? Does it avails me? Can I get something? No, let me go full screen. Because I want to work another problem quickly. So here your position, so you would get A dot B. So whatever, in this case, it would have been AC dot AB equals to the modulus of AC modulus of AB because of the angle between them, right? But in this case, you have the unit vector. Now this, if you have a unit vector, this is 1, right? Because the modulus of AC is 1, modulus of AB is 1. So therefore, it's just the multiplication is a product of the two unit vector UAB times UAC, which will give you a scalar value, right? Remember, this is a dot product now, so it will give you a scalar value. Once you get that, is a cos inverse of that, right? So that is simply what you do right there. And after you have done that, because you need the angle to do the projection, once you get the angle now, you're gonna do the projection. So you get the angle, which is 31. So it's FAB parallel to AC, which is divided by AC. Is the same thing to say FAC parallel to AC is equal to FAC because of the angle, because this AC is projected onto AB is projected onto AC. Was that what they asked? It says tension in AB is projected. It says AB is projected onto AC. So, right? So it's AB, the cos AB of it, once you get the angle between them. Right? And you'll get, so you have AB already, and it's the cos of AB. This here, please pay attention to it. I will send you the information. I want you to sit and read it, practice it. It is similar problems. You may see similar problems. So it says method 2, FAB parallel to AC is the same thing as FAB times the unit vector of AC. So if you do it, if you use this formula, same difference, right? Meaning that you get what? AB times the modulus. So you get the value of the force times the unit vector, pardon me, right? So that is method 2, right? You get pretty much the same thing, right? I think we may have used this one in class before. Not necessarily this one, but it's the same thing. So you will get that result. All right, guys, I'm gonna beg you, please, for at least 15 minutes. I'm gonna try and find a frameworks problem because I intend to put one on the quiz. So let me find a frameworks question quickly, just to hopefully one work out already, so we can go through aspect of it.
Question, sir. What's the answer? For quiz 4, sir, is it a case where we're not having a quiz 4 because you're doing the mid semesters?
You are going to have quiz 4 and quiz 5 going up, but I pull it back because I wanted to just go through I want to go through stress again, because I don't think that you got the time to work any problem of such on the topic. So let me just see if I can find. So I gave you a lower, and you have both slides, right? So I'm just gonna look at a section of a slide that that's probably one problem. So we did both method of section and method of joint. So briefly, I'm not gonna go through all of this. Let me just try and find one of the problems. We look at zero force, we look at method of joints. I just want to find one simple one here. Just let me see if I find something with joints quickly, just to all right, I want to find a joint problem because some of you don't understand to use the joint or you haven't practiced it yet. All right, we would have done these simple ones in class. Okay, let me use another slide. Did you all go through, everybody here went through this one, the last question on this? It worked out the joint properly. Let me just discuss it. So you'll have this one typically. I know a lot of you wouldn't have gone through this. I think I gave you this as one of your questions to do. Did I? In your quiz, did I give you this question here to do? Are you seeing it? Can somebody respond quick for me? I know the time is gone. Hello?
I'm not too sure, so I don't remember. Let me understand.
All right.
Sorry.
All right. Let me look at the question because I'm not gonna do it if you have it as a quiz. Because I was just gonna work a little part and show you. Hold on. Let me just check. I want to see the quiz what you have for your assessment. You know you have an assignment there. And I was looking at question. Yes, no, it's different. Oh, that's the one you have. Okay, all right. I'll show you a little bit how to do this one. Let me just go back to this slide and we can discuss this one. Let me just, all right. I may borrow 20 minutes or so from you. See how quick I can go through this one. All right. Let's drop this here. I'm just gonna work a little part of it. All right. I know that I'm taking up I'm encroaching on your time. Is it okay? Can I go on another 20 minutes or so? I know how many persons are
Good with me.
here.
Yes, sir. You can go on do your thing, sir. I'm there. I listen.
All right, cool. So, all right. So we have this question. You get typically a question like this. All right. Now, one of the first thing you do, you will need to work out the geometry. You cannot work the problem before work the geometry, right? So before you even draw the free body diagram, and remember now you need to draw a free body diagram for each problem you get. You must do the free body diagram. If you don't do the free body diagram, you're gonna end up with problem. All right. All right, so I want to make it a little bit smaller. It's so big. It's taking up all of the space. All right. Oops, too close up here. Can I get it on a different page? Yeah. All by itself. All right. Now, I didn't get to do a lot of this with you. Workout. So I think some person might still be in the gutters with it. All right. So you draw a free body diagram. But before free body diagram, we're gonna look at the dimensions. So this is 2. This dimension here is 3. This is 2. All right, so we need to get this angle here. All right, we need to get some angles and to start off. So right there now we see a triangle. Look at the geometry carefully first, guys, before you start the problem. So this is 3 and this is 4. So right there, you know, so this is 5. There's a ratio there. So the angle here, theta. you could say that this is sine theta is equals to 3 upon 5, right? And cos theta, well, it's one of them you needed to do anyway. What's the angle for that one again? What are those ratios supposed to be? 3 upon 5 is what again, right? Let's give me the angle, because we'll work with the angle rather than the ratios. It's sometimes a little bit easier. You just kind of know what kind of triangle we're in. So the sine of that is giving us what now again? 36.9, right? So this is 36.9. And this one, so up here is 53, the angle up here, but we don't need that. So we know that this is 36.9. Okay. This one now is, if you need that, you could work it out, because the triangle there is simple. So make sure you work out get these first. 3 before you even start to do it.
For instance, for the triangle that you use up top, sir, you just use because the height is 3, so you just use a regular 3, 4, 5 triangle.
Yes. But look,
Okay, sure.
look, this is 3, and down here is 2, 2. So you're getting a 4, 3 triangle. You see it? You didn't even have to go there, so you could have just used tan and know the angle here. You understand me? But it's a 4, 3, 5 triangle. So it's given. All right. So once you know that angle right there. This other one here, you use tan. The tan of 3 divided by 2. That is, we know that I want to. So this is 56.3 or something like that. 56.3. So we know those. All right. Now that you know those, what's the next step? We need to draw our free body diagram. So you do a quick drawing. I'm gonna be as quick as possible. You do a free body diagram. I'm not gonna perfect this drawing here, guys. Oops, this is too bad. Not looking too good. So start over. Come on. All right, so let's do a free body diagram. Yeah, something like that. All right, we're gonna do another part. All right. It's not gonna be drawn by scale, guys. Unfortunately, I'm trying. All right, and then you're gonna draw the section down here. All right, and then you have draw these first. Draw these first. Oops, that line is totally out. So you have this one. All right. And then now, how many you have? Another one in the middle. Why? The draw just scale that tall. Osh. Then this one is drawn somewhere here. And this one here. All right. And then I just draw it. All right. So you draw your free body diagram. All right. And then well, I'm not missing anything. I'm missing something. Oh, I'm missing one element here and another element here. All right, so you draw a free body diagram. This is a pin. So you could say you have one going in, a force going in, and one going up. All right, and there's a roller here, so you have one. All right, and then right, so you can put on your arrow on them. All right, and you put on the arrow going in. So now the labeling, this is A, B, C, D, E, F, H, and up the top is I, and this is J, this is K. All right, I'm gonna show you, hopefully just maybe metal one. All right, so the first thing you do here, guys, you label it. You're going to find your global forces. All right, so your global forces, how do you find your global forces from this now, guys? You're gonna use your equilibrium equations. So remember that this is 3. All right, and you know the others are 2, 2. The others was 2 too. Yeah, everything is 2 coming right along. So everything is 2. 2, 2, 2. All right. You have some other. Oh, we left out some the forces. Let's put the forces in. So you have one here. You have one here. Have one here. Have one here. All right. Those are the forces you have. All right. This is 4 kilonewtons. Proton, 5 kilonewtons. This one is 8 kilonewtons. This one is 6 kilonewtons. All right. What you do right here now, you are going to use your equilibrium equations, and they are sum of your forces in the x equal to 0, sum of your forces in the y equal to 0, and take your moment, sum of your moment, you could take anticlockwise as positive about some point. All right. All right. In the x, we already know by inspection that the sum of forces in the x, in this case, is equal to 0. So it's ax is equal to 0 because it's the only one acting in the horizontal. All right. We don't have another force acting horizontal, so that one is 0. Sum of the forces in the y equals 0. So now you have ay going up. You have a -4 coming down. I'm not gonna write the units beside it here, guys. Let's rewrite those. So you have ay coming down, ay going up, pardon me, positive, plus, oh Lord, all the force coming down are minus. So this is -4, -5. Let's put the arrow on them. All right, and then you have -8, -6. And the gy is going up in the giant, so it's plus gy equal to 0. And that gives us an equation. So you have ay plus gy. What is what? This is 9. That's what? 14. 14 and 9. How much is that, guys? So you could take that over. 14 and 9, guys. Y'all sleeping on me? Hello? Anybody there?
There are around 23, sir.
23.
Yeah, so you guys are now working with me. All right, good. So we're done there now. All right. We're gonna take moment about A because we can take moment anywhere, but I'm gonna take it around A. So we're gonna sum the moment, taking anticlockwise as positive, around A equal to 0. So let's look at the drawing now. It's a little bit smaller. Zoom in. All right. So you can see the points while I'm taking. Right. All right. So now let's take a moment. So you put your hand right here, and then you're gonna take the moment. The first one is 4, and it's 4 is gonna turn it into the clockwise, which is minus. So it's 4 times 2. The distance is 2. The next one is also gonna turn it. The same thing is minus 5 times 4. Any question asked there? So from A to C it's 4, turning it into the clockwise, which is minus. Now up to E, how many we say have 2, 2, 2, 2. How much that's 8 up to E? The E is also turning it there, so it's 8 times 8. And up to K is what? 10? No, so it go 2, 4, 8. No. Yeah, up to E is 10. Up to K, sorry. So it is minus 10 times 6 because 6 come down right here in the same direction. Plus GY times what? 12. Because that's 6. Any question there? Any question? Everybody good?
Sir, how you get the 12 again, sir? The GY
Well,
times
add up
12.
all the distance from A to, what's that point? G. Up here says G. So,
We
come
see
on,
we
add up
see
all of
12
the
now, sir.
distance. It's yes. So it's
Anything
12
on
and
E10, sir.
G is going up in the anti-clockwise, which we consider positive. So this is 8 20 minus 20 4 minus 60 plus 6y times 12 equals to 0. So add up all of those for me, guys. What do we get for that? So that's 60 plus let's check that. Everybody working with me? So that's 64 plus 60. All of these minus plus 28. So it's
Sir,
minus 120,
minus.
minus 120, 152.
Yes,
So,
sir.
so GY, hello? Someone said something?
No, sir. No, sir.
All right, everybody get that? So therefore, GY, oh, I'm right a bit, huh? GY, so GY is equals to 150, come on, 152 divided by 12. How much you get for that now? So you get
Sir,
12.
about 12.6, sir.
Yeah, I'm trying to get my writer here back to 12.67 kilonewton. And from that now you substitute it back into equation. I call it, well, you could call it, that is 1, this is 2, and then this is 3. Right? So you put it back in equation 2. So you substitute in equation 2 GY. Oh Lord, why am I writing? GY equals to 12.67, which is basic for you guys now. You're supposed to be island can do these things by Bappe high. So this is so AY is equals to 23 minus 12.67, which is equal to what now? 10.3. That's what you had said? All right. So now that you find that, we're gonna do one joint. The time that we have, let's do one joint. So you're going to you're gonna consider a joint. And I'm gonna consider joint how many things we have? This is L. I didn't label everything, I didn't label one. So we're gonna consider a joint. And we'll consider this is L. We're gonna consider joint A. So when you consider joint A now, all right, I need to make it small. So okay, I can see it on the screen over here. I need the figure. So I can pick up the joints. Let me just copy a little part of it. I'm gonna copy this. Any one of them will work. All right. Where do have the values? You can tell me the values. I will go back and look for them. So for the joints, as we're gonna say now, you must make a statement to say consider. I will need to know what you're doing. Consider joint A, right? And you don't have to put AY in it because you know it's 0. 1 going up. We're gonna consider that this AL is in tension. We don't know if it is in tension. And this is L, so you call it FAL. And then you consider this AB also in tension. So you're gonna call that F, AB, and AY. What was AY value again, guys? We just work. Is it 10.3? All right, 10.3. 0.3 kilometers. What was the angle subtended that we worked out? 36 point, the angle was 36.9. This angle here, alpha, which we need now. All right? So we need the angle alpha, 36.9 for that. Now, why we need that angle? Because we want to know there are components of this force here. One here and one here. Right. So component of this force, right? This is angle is still 36.9. So it's going to be FA. Oh Lord. Right here, see. If you make one mistake with it, it mess up the thing. All right. So it's component here is FAL sine 36.9. And for the cos, it is FAL cos 36.9. So the component, one component is in the X, one component in the Y, right? All right. So now we use just your equilibrium equations. Quick and easy, and you are good to go. So let's write them now. So we want to consider the sum of the forces in the X equal to 0. Let's put them here. Right? You could do the Y first. Let's do the Y first. See if it's give us an answer. Let's do the Y. Always tell you to do the Y first. But you could just write the equations and work out the one that gives you. So the Y would have AY positive going up, which we know. Then you have plus FLA sine 36.9 equal to 0. So right here we have an answer. So right here we know that FLA is equals to minus 10.3 upon sine 36.9. What value do we get there now? It's divided by sine, oh Lord. So it's 10.3 divided by sine, minus 10.3 or sine 36.9. So you get what? 17.1. 115. If you want to write it, kilonewtons, that is minus. All right, so we see that that is in, so this is a compressive force. You could write it as 17.2 and put a C, kilonewtons. All right, tell you that it is in compression. All right, we're not finished. We need to find AB now. So the next expression, next equilibrium equation, sum of the forces in the X equal to 0. Now we have one component FAB right here. So we need to write it down. So you have FAB, which is positive, and you have another one up there, which is FAL cos 36.9. Do we have any more? No, I don't see any more. All right. But we have one. So FAB we know already. We don't know, so we're gonna find equals to minus FAL cos 36.9. Right. So this value is going to be minus bracket 17.2 cos 36.9. Right. Okay. What value do we get here now? Time cos. Time cos. It was minus, no? Put in a minus, please. If it is minus. So it's cos. If it is minus, you have to put in a minus. So it's a positive 13.7 kilonewtons. Right? So that one is in tension. Right? All right. So now we have found two forces. You could go again and find and take another joint. You could choose to take, you don't want joint with too many unknown. So you could take joint L, right? You could consider joint L. So you're going to consider joint L. All right, we're going to draw joint L again. Joint L was, all right. So now we know that this is in compression and it's going into the joint. So we're going to make it positive because it's going into the joint. Right? This is L right here. Right? So we're going to change to that positive. We're not going to put it in tension. So we're going to assume that it is positive going into the joint, which is correct. And then now we're going to say that LK is in tension. But we don't know otherwise. We're going to assume so that LK, so this is F, LK, this was F, AL, and then what's the next one? The next one was, where is it again? One coming down. We don't know, I don't know, I'm going to make an assumption that is in tension. That's an assumption. All right. This one will have two components, and this one will have two components. That's the same. All right. Everybody following? Who is with me? Yeah, I don't know who is left here, but maybe just a few of you. But I'll just try and tag on. Let me see. I'm trying to get different color markers to use. Minus. All right, so that those are the direction that we're assuming. We know one, we don't know the others. So we can write that this component, we know this angle already, which was what? 36.9. Do we know the angle up here? We're assuming if it is, we can assume that it's, once it's on, we draw an horizontal to hit the angle to the horizontal. We can assume, I'm trying to remember the original figure. Let me see the original figure. Yeah, they're sloping to the same direction. So once you draw an horizontal, it's going to give you the same angle here. So you see 36.9 works. Where's my right hand? Oh, it's gone. So this here I'm going to call is 36.9 also. All right, so this is going to be F LK sine 36.9, while this is F LK cos 36.9. This one is F AL cos 36.9. And this one around here is the same thing. Where can I write that now? Space kind of limited. This distance here is FAL sine 36.9. You know, so that is that. All right. That might look a little bit ambiguous. See? You don't want somebody see this they don't know why I put that over there. Let's put that. If I can pick up a writer for that. Don't like using green because I can hardly see it. That line there. Right? All right. Pick up back my black right there. All right. So those are the components we have. Oh, this is another one here. What was that one? That one coming down, we didn't identify it. It is LB. I'm going, this is B. So this force is going to be FLB. And we assume that those are in tension. We don't know if they are, but we made an assumption. All right. So we know this one already. What was its value again? FLA was 17.2. And we say that because it's going in the joint, we make it positive. We're not, if you had put it in tension, you would have to put it back in minus. So it's 17.2. That was its value? 17.2, right? So we have it at, right. So here now, you use your equilibrium equation once more. Simple. Equilibrium equation all the way. I'm going to hint this to us. Right, again. So this is F. Any one of them, let me see which one is advantageous. I'm going to write the Y again, see if it gives me anything. So the Y would be FAL sine 36.9. Then the next one would be plus FLK sine 36.9, right? Plus, this one is minus. Now, those are positive, but this is minus now. Minus FLB. All right. We have quite a bit of unknown with this one, you know. So this is it. All right. But guess what? I think well, we have quite a bit of unknown. We have what? Oh, we have we have LB and LK. Oh, okay. Two unknown. And then you have this other one. Sum of x equal to 0. So you will have this first one, this one is FAL cos 36.9. And then the other one is plus F, the two positive, FLK cos 36.9. Oh, you see what is happening here though? Who see this? So one is minus of the other.
Both angles are equal.
Yeah, one is minus of the other. You see that? Well, we know FAC. Let's put that value in and work them out. But we typically know one is minus of the other. So FLA is equals to, so typically these are both cos, so they drop out. So what we're actually saying, this is minus F. But one is minus of the other. I would know that this one was what? What is value again? 17.2? I think it was, yeah, 17.2.
Negative 17.2.
No, we changed that it going up in the giant, so we made it positive. It means
Yeah, but
that
you still use the sign, even though it.
no, I'm saying to you, listen carefully. Once you put it, it is compressive, and if you had changed it and assume that it was in tension when it's in compression, you would keep it as minus. Once you keep it going into the joint, which it rightfully is, going in compression, you don't use a minus sign again because it's going weird. It's a compressive force. So you keep it as positive. Make that clear. You see, if I'm saying, if when you drew this, you had turned it down, coming down opposite to its direction, put it in tension when it's compression, then you have to use a minus. Once you put it, keep it as compressive, which it is, you have to make it positive. That's a little nuances you need to know. So in other words, if when you get the joints, you assume everything is tension all the while, you keep the sign. You get what I'm saying? If when you are drawing your joints, you get one that is, so you get one that is compressive force, but you're going to do another joint now and you put everything in tension, even though you know one is compression, you have to keep the signs. All right, am I clear?
Yes, sir.
Good, right. So therefore, we are saying here that FLK is equals to minus 17.2. Right. So that's what I am getting from, where's FLK? That's what I'm going up. All right. And from this now, I can find, what is my unknown here now? I can find FLB from the first equation. So that is equation 1. This is equation 2. Right? I use a different color so as just to kind of not confuse you. Let me use like another milder color, blue. All right. Sorry to use that one, but I mean, really and truly, you're not supposed to use such a bright color. But I had to use a contrast. Everything is dark. Let me use black. We got the black color. All right. So the black here now is so we can substitute. The first, we're gonna go back with the first one. So it's FAL sine 36.9 plus FLK sine 36.9 minus FLB. So we're going to substitute now. So you're going to substitute for AB. So this is 17.2. Remember, we called it positive now. Sine 36.9 plus this one now is minus. Because it just gives that it minus. You not do anything else with it yet. So we work with it as minus. Sine, if you are doing a different joint now, and you assume that it's going into the joint, then you have to make it positive. Minus FLB equal to 0. All right, what that gives us? That means that FLB, but hold on. This is 17, so that one is 17. But that means FLB is 0. Is a 0 force member. You see that though? That's what it is telling me. That's a 0 force member. You get that, guys? Mean
Yes.
that if you take it away from there, it John, nothing will happen because it's not doing anything. That's what it is saying. So that is one way. And you know why it is true it's a 0 force member? It says when the members are collinear and there's no support at that joint, then the member is a 0 force member. So you see, if there's any load at the point L, any load at the point L would mean that that member there would be a 0, would have a value. But because there's no load at that point, the member LB is a 0 force member. And I can tell you by inspection, what you call that one? That one look like FH, look like a 0 force member too. Right? So by inspection, we could identify a number as 0 force member. It looks to me that another 1 or 2 members might be 0 force member. You have to work them out and check them. All right? But the rule says 1. So I know JD look like a 0 force member because members are collinear and I'm looking good. Let me see if that one is a 0 force member. Yeah, that one look like a 0 force member because CD and DE has no support at that point. So it looked like JD by inspection is a 0 force member. So I have at least 3 members that are zero force members. What I want you to do is, so I have done 2 joints for you. I will show you briefly how to do method of section. I won't do all of them. I'll just draw the diagram for you. Cut it, show you where I cut it. It asks for JK, CJ, and CD. So we could drop a line across it. Let's choose a line. You want to drop a line across it. It's here. You're going to cut it across here. Right. And when you cut it across there, you could choose what members. I'm going to copy it. Let's copy it. I'm going to, do I have a copy function here? Where do I get a copy function? Oh, let's see if I have a copy. I'm going to select an object. Select object. Yeah. And I'm copying it. I'm copying it. Let's copy it. I'm going to be very quick. I'm not showing you what to do. You're going to have to finish it, guys. All right. So you draw that. Now that you have values for it, you're going to have to draw a quick free body diagram. I don't even think I'm using it. I don't think I have the time to use a ruler, do I? All right. So you draw back a quick member here. Let's get back a block right now. Where's the block? So you draw back a let me see if I can draw something quick. You draw it up. All right. You don't have to draw AX because AX has no value bearing the problem. Just these things are. All right. So you have one there. Oh, these lines are so bold. One there. Let's draw a line here. All right. When you finish that, you draw the next one. About halfway. Any other line you draw must be broken. And then you do the same thing with this one. About halfway there. You dot it to that point. Can use J. J is relevant to you. Oh, I can't do any writing yet. And then you do about there. And then your dot coming out. D. All right. And then you had another member here, which I told you. Oh, another one here. I have another one going up 0 force. Not really holding anything. All right. So you could put arrow on it now. All right. So you put arrow on these. Arrow going in those direction. All right. So you're assuming that they're intention, eh? And you label them. So this is K. This is C. This is J. And this is D. You're gonna label this F, K, J. You're gonna label this F, C, J. All right. Not looking so neat there. And you label this F, C, D. All right. This was AY. AY was what again? 10.3. Correct?
Yes, sir.
And you had another force coming down here, which was what? 4 kilonewtons. You have another one coming down here. Wow, we're gonna have to do some cleaning here. But I have to show you because I intend to give you one on the test. So this is one was 4. No, one was 5. Hold on. One was 5. C was 5 kilonewtons. This is 4 kilonewtons. That is 10 kilonewtons, right? This is angle is 36. You know that. You know that these distances are 2, 2. You know the distance between this distance here is exaggerated, but it's 2 also. Right? Out to D. This is C. C. This is B. B is right here. And this is A. Some of the distance are exaggerated. Right? Or show my sketch. The sketch is not up to the level. But trying to work with it. So those are the sketches. The broken line is show you where it goes over. Now we can take moment and find CD. As an advantageous, I'm going to take moment at J. So I'm going to sum off the moment. Let me get a writer here. This one look a bit too fine. Take the moment at J. Why? If I take moment at J, FKJ and FCJ gone out of the problem. And I'm only left with FCD. So I'm going to take moment right there. So I take in moment at FJ anticlockwise, positive. Right? You're going to finish it, you know. I'm just working that part. You're going to finish it. So well, let's take moments, please. All right. So let's see if we have enough thing to take moment there. We'll know that yeah, so we're gonna take moment right about this point right here. You see the point there? Everybody see that? And the first force that we're going to contend with is the CD force. Where is the perpendicular? We know that that is 3. We know that this is 2. The force is going that way, so the distance from J is 3. And it is going to turn it anti-clockwise. Can you see that it's going to turn it anti-clockwise? It's going that way. So it's going to be going that way. Can you see that?
Yes, sir.
All right. So therefore, this is going to be FCD times 3, which is positive, because that is and then the next one now is going to do the same, the 5. So the 5, what's the perpendicular distance? Is 2. If you look up top, between K and J is 2. So it's 2 is going to turn it. So it's times 2. Positive again. What about the 4? What's the distance the 4 going to turn it? If distance is the 4 coming down here, what's the distance from what's the perpendicular distance of the 4K force? Anyway you want to look. Whether you want to look up here, what is the distance? It must be that it is going to be 4, because KJ is 2 and the distance between right here is also 2. So it is going to be plus again 4 times 4. Do you see that it is 4? Do anybody need clarity? How many persons leave online? Only 4 persons? I don't know how many persons are still here. So it is 4. I'll send the video out. So it's 4 times, so it's 2. Let me check that again. The 4 force, this is 2. Let me write them down for clarity. Let me see if I can put a color here. So this is 2. And this this distance here is 2. Coming from K to J, is 2. So it's 4. And this is the perpendicular right here. So it makes right there. Coming down. So it comes down that way. Right? So it's going to turn the body around in the anti-clockwise. All right. Next one. Last one left now, which is going in the clockwise, which is minus, which is AY times, how much distance is that? 6 equals to 0. Do you agree? So therefore, FCD times 3 is equals to 5 times 2 minus 10. 4 times that, 16 minus 10.3 times 6. Right? So therefore, FCD is equals to what's that work out to? So it is 10.3 times 6. That's 61, right? Plus 16 plus 10. So I'm getting minus. Am I correct? No, I'm supposed to get one as plus. No, so it go. One of them is plus. This is plus. So I'll be wrong. Nobody caught that? So it's 26 minus the 60. 10.3 minus 26. So it's a positive 35.8 divided by 3. So you're getting here 11.9 kilonewtons. All right. So that's what I'm getting for it. You can double check it. And I'm getting it that it is in tension. All right. We can look, right. Once the signs are okay, then the answer should be correct. Any questions?
Awesome.
Right. Once the answer is I don't know the answer. I didn't look at it before. Right. Once those, and so we are saying that it is in tension. That's what, once these are correct. So that would have been 26 minus 60 odd. Then we get in that 11.4. Once we didn't make any error in terms of sign. Right. So that's from J. Let me just check that distance. How much is that? 6. Yeah, 6 we have. And so, all right. What's the procedure you're gonna do with the others? With the others, you could take moment probably at C. And then what that will do, you could find Fj from that. If you take moment at C, then only 2 forces you would have in your problem. You would only have the 4 kilo AY and the same FKJ. So you only have 3 global forces that will be in your problem. And you could do that and then use your equilibrium equations and solve it. And that's as easy as it. You understand what I'm saying? Any question there? All right, guys, I've kept you long. You're gonna have a long day tomorrow, whatever your activities are. So I will not hold you. Right, your test, I'll put a little framework question on it. I won't put one to kill you because I know some of you don't get a chance to practice a lot on it. So I will give you a little baby one to make sure that you're practicing and to see if you understand anything that I have taught you. I suggest go through the slides. I both give you the lower slides and the upper slides. Use them to your best. All right?
Sir, can I ask a question?
Yes, of course.
Sir, no, it's about the test. How many questions?
Can I put this thing on pause? I'm gonna put the recording on pause so we discuss that outside of 1 second. Let me pause the
Okay.
record.